Welcome to Tech Talk with Hughes Performance. My name is Pete Nichols. I'll be your host today. We're going to be talking Converter 101 today. We'll be touching base on overall torque converter construction, purpose behind the components, and some basic operating theory. If this is your first time tuning into our channel, do us a favor, hit that subscribe button. Check us out on social media. We're on Facebook, also our website, hughesperformance.com. So moving right into it today, torque converters are a little bit of a mystery in our industry for a lot of people. Some of this may be rudimentary for those of you watching, but some of this basics you may find very useful. So when it comes to overall torque converter construction, all OEM converters are based on steel construction. If you've been in the aftermarket racing industry at all, you'll see some billet aluminum examples, titanium examples, half and half. Today we're just going to be talking basics. So this unit here is one of our entry-level 9-inch torque converters. It's a display unit. Overall construction is steel. This particular unit's based on a GM product. We also offer them for Ford, Chrysler, and even import products. Jumping right into it, we have a torque converter pump hub here, and even though this is a relatively simple looking piece of steel, it actually does several pretty critical jobs. Your front pump seal, which is a rubberized lip seal housed in steel casing, it's located in the front pump assembly right here, rides against this pump hub. That helps provide a fluid seal between the pump and the converter. You also have the front pump bushing. This is a steel backing, Babbitt layer, and a dry film coating. We like to use this style of bushing in most of our transmission builds wherever they're available. This is also found in the front pump body right behind the pump seal. That bushing rides on the pump hub. This bushing actually creates about 90% of your sealing between the hub and the pump. So if you're getting a leak that's consistent from your front pump area, it could be a bad seal, but there's also a good chance that it's actually a bad bushing, especially if you replace the seal and that leak seems to persist. So in that event, you're definitely looking at pump removal and bushing replacement. Behind the bushing, you have the pump gear set. You can see that the pump hub is machined with slots that engage drive tangs on your inner pump gear. That engages like so. The inner pump gear turns the outer pump gear, all of which is housed inside of your front pump assembly in the transmission. And the purpose of that is to create pressure to apply the clutch packs and the bands, and to also provide fluid flow into the torque converter. You know, not all converters are created with a slotted pump drive. Those of you who are familiar with Ford products, a lot of Fords use a flat that's machined on the hub on both sides that engage a corresponding flat on the inner pump gear here and here. Same principle, just a different style. There are also some Mopar and import products that use that. And GM has even actually gotten into the flats on the pump hub, as this is actually a GM converter for the new 8-speed 8L90E platform. So moving on from the hub, we're going to go ahead and pull this converter apart so you can see what's going on inside. This half of the converter is normally welded to the cover here, so this is actually your engine-driven component of the converter, even though it's on the back side in the transmission. This is called an impeller. Some converter builders also refer to this as a pump. If you hear this called a pump, different than the front pump. So technically you have two pumps. You have the front pump in the transmission generating line pressure and converter charge. You have the converter pump that's actually physically pumping fluid from the impeller to the turbine. You can see the construction. You have a set of vanes. You have what we call a turbo ring. The vanes are folded over to the turbo ring. The spot brazing that you see here is something that we do. OEM converters don't feature that. This is a strength enhancing feature. It helps prevent damage to the fins, prevents them from folding over or tearing from the tremendous hydraulic forces generated inside the converter. We also go in and braze in the outer impeller fin here. You'll also hear a term called furnace brazing if you've been in the industry at all or an enthusiast. That's a little bit different. It's also a strength enhancing feature. This converter is a good example of something with furnace brazing. You can see the copper coloring around the impeller vanes. It's also in the turbine, and that's actually brazing that's flowed in there, and it runs the entire length of the vane. So it not only strengthens it, but it seals the internal components of the converter and keeps the fluid moving efficiently between the two elements. Again, not all OEM converters have that feature. Interestingly enough, it does date back to OEM technology in the 60s with Mopar. Their Hemi torque converters, the 11-inch models behind the Hemi and max wedge engines in front of the torque flight transmission were all furnace brazed right from the factory. Racers picked up on that and adapted the technology to their aftermarket converter builds. So moving from the impeller, you have your intermediate element of the converter. This is called a stator. You can see it also has vanes, has bearings on each side. Some stators feature thrust washers. It just depends on the overall converter design. 99% of the converters we build here are performance oriented, so they're always going to have bearings on both sides of the stator cap. Bearings obviously wear a lot longer than a thrust washer does. Bearings have a lot higher thrust load capacity than a thrust washer does. So bearings are definitely a good thing in your converter assembly. We're going to talk a little more about stators and the one-way clutches that are inside of them in an upcoming episode, but for now we're going to stick to the basics. You can see the spline here inside the stator, and that actually engages the stator tube on the front pump, which is this splined element here. You can see the spline just matches up. The stator can rotate in one direction thanks to the internal one-way roller clutch, and not the other. It locks in the other direction. We're going to come back to that when we get to some basic operating theory. So moving on to the next element in the converter, we have the turbine. It's a splined assembly. It engages the input shaft and the transmission, and is the component that actually provides drive between the engine and the transmission from the impeller to the turbine to the input shaft. So what you have going on is a fluid coupling inside the torque converter. We're going to touch base on that as well when we get into theory. This is the cover. You have the option of a thrust washer or a bearing in this area that rides between the turbine and the cover. Again, that's just based on what type of converter it is, overall converter construction, build specifications of the converter. A lot of our converters have a bearing in this area, some have thrust washers. Again, it's just based on the overall build. This is the cover. This is the piece that physically bolts to your engine. You have a pilot that engages the rear of the crankshaft and aligns the converter. And then, of course, you have mounting pads where you have a bolt attachment between the torque converter and the flex plate. Converter pilot fitment to the crankshaft is very critical. You want to make sure that this pilot doesn't bottom out inside the crankshaft, otherwise you can have thrust bearing issues in your engine. You also want to make sure that it fits properly. If it's too loose or if it's too tight, you're going to have other issues. If it's too loose, you're not going to have proper centering of the converter. That can cause premature wear in your seal, your bushing, and your pump gear. If it's too tight, the converter can't float at all during normal running conditions with normal expansion and contraction of the metals. And again, you can run into engine thrust bearing issues. So checking this clearance before you assemble everything and just test fitting the converter to your engine before even putting the transmission back in is always a good idea. When you have your converter installed, we're generally aiming for an 1/8 inch to 3/16 of an inch of pullout from the front pump towards the engine in order to mate to the flex plate. If you have less than that, you probably don't have the converter engaged into the pump all the way. If you have more than that, you can use some premium hardened flat washers as shims to take up enough of that gap between the converter pads and the flex plate to establish the correct converter pullout. It's not going to compromise strength or give you any issues in the future. So for a basic torque converter, that's the construction, that's your components. Moving into theory, that's an area that some people kind of view as black magic. There's a lot of confusion about what a converter does and doesn't do and what it's capable of, and we're hopefully going to help clear that up for you. On a very basic level, you have a driven element, the impeller, the pump, providing a fluid drive to the turbine. We're going to give you a little demonstration so you have a visual of what that looks like. Again, this is just on a basic level. We have an electric fan that we're going to turn on. You're going to see as the fan starts to spin and move air, this little fan blade is going to start turning. That, on a very basic level, is what's going on inside your torque converter. You have the impeller, or the fan, it's taking fluid as it's being fed into the converter by the pump. It's traveling through the inner vanes here to the outer vanes, and it's being slung from centrifugal force towards your turbine. And that fluid that gets flung at the turbine hits these outer fins and provides drive, just like what we saw with the fan demonstration. Because the converter turbine is splined to the input shaft of the transmission, that's where you get your drive motion. Now, if you had just a pump and just a turbine, you'd have what we actually call a torus, or a fluid coupling. It's not an actual converter because there's no torque multiplication taking place. That's actually the early 30s original design before they figured out that you needed a stator to provide acceleration. So with a torus or a fluid coupling, you'd only have X amount of drive speed and then you have no more acceleration capability. So a vehicle would only be able to go a fixed maximum mile per hour based on the coupling ability of the converter. Moving forward in technology, guys figured out that you have to recover the energy that's lost between these two components. That's where the stator comes in. By adding a stator between the two elements, we're taking that fluid that's in a high rate of vortex flow, so circular flow between the two elements, pumping through here, out to here, up through the inner vanes, and we're redirecting it via the stator. So when that fluid exits your turbine from the inner turbine vanes, it hits the vanes of the stator right here. And you can see that the stator vanes are angled and they have sort of a ramp shape to them. The stator basically takes that fluid and redirects it to the pump. The shape of the vane and the angle of the vane provide fluid acceleration. So as this stator is accelerating the fluid back to the pump, it's actually increasing drive force to the inner fins on the impeller. That's what torque multiplication is. You may hear the term K-factor used by some builders. It's really what they're talking about. It's the maximum torque multiplying capability of the torque converter. K-factor is a little bit of a smoke and mirrors thing. It's really helpful in an OEM application where you're dealing with black and white absolutes. In the racing industry, even the high-performance street car industry, heavily modified diesels being used for towing, anything like that where you're dealing with engine modifications, gearing modifications, transmission modifications, different weights than OEM spec, K-factor kind of flies right out the window. So if you're dealing with somebody that's trying to sell or promote or market something based on K-factor, you're probably not getting all of the information that you could when it comes to selecting the proper converter for your combination. So you just want to be wary of that. So as we're accelerating fluid, we're contacting this inner impeller fin from the accelerated fluid, we're multiplying torque, we're increasing drive force against the impeller. This being the engine-driven element, it's effectively taking X amount of foot-pounds of torque that the engine is generating and it's increasing it up to the point of stall speed in the converter. Most converters are going to have anywhere from 1.2 to 1.8 times the ability of torque multiplication of what an engine's generating. It's just a real broad general figure, so don't stick to that too strictly. But as an example, if your engine's generating, say, 400 foot-pounds of torque at 3,000 RPM, and this particular converter were to multiply that by 1.5 times at that RPM, you're effectively delivering 1.5 times the amount of engine torque to the input shaft. That's why a car equipped with a converter has really great acceleration characteristics. When you're dealing with a manual transmission and a clutch, you're relying strictly on multiplication from gear ratio. You don't have this hydraulic device multiplying torque for you. In a drag racing environment, that's why you'll typically see an automatic car be capable of running the front half of the track quicker than a clutch car can. That's not an absolute. There's plenty of fast clutch cars out there, but as a rule, we do see improvements with converters and automatics versus a clutch in a max effort type of combination. You'll hear a lot of talk about torque converter slippage, torque converter efficiency, and because this is a fluid coupling, we don't have a mechanical link between the engine and the transmission that's actually physically driving. It's all fluid force that's providing the drive. Because it's fluid, you're never going to have a true one-to-one ratio unless you get into a lock-up torque converter. We're going to touch base on that in the next episode. When you're talking about slippage, when you're talking about efficiency, you're talking about that loss of drive between the impeller and between the turbine. People get really hung up on converter slippage and efficiency. It is important. I don't want to downplay that, but there's so much that goes into converter design and how a combination works together that having the lowest possible slippage number isn't always what's best for your race car or your max effort street strip car. Again, it's all about what the whole combination wants. Torque output, horsepower output, RPM capability, weight, gear ratio, tire size, what your expectations are for the combination to perform. That's all going to affect how the converter functions and what converter is right for your combination. And that's why it's so important to call a professional like us here at Hughes Performance and get a recommendation on what your vehicle needs rather than just price shopping or going off what catalog recommendations state you should be running with your vehicle. Important side note, since we're talking about fluid coupling and hydraulics, it's really important to run a good quality transmission fluid in your transmission and converter. Because you only have a fluid coupling ultimately delivering all your engine's horsepower to the rear tires of the transmission with an automatic, you can run some really cheap generic parts store fluid and in a high stall converter, a high performance application, or a drag racing environment, that fluid's not going to hold up. It doesn't have good pressure additive packages in it. It doesn't have a good viscosity index. And truth be told, your generic parts store, cheap 99-cent a quart type of fluids, it's all recycled oil. So spending the money on a good quality fluid is well worth protecting your investment that you're spending on your converter and transmission assembly. We at Hughes Performance worked closely with High Performance Lubricants, and they blend our synthetic racing Type F for us. It's a fantastic fluid. We have it in stock all the time. We recommend it for use with all of our products as well as most of our competitors' products. That being said, there are a lot of great fluids on the market. Do yourself a favor, spend the extra money on a good fluid, you're protecting your investment. So for today, that pretty much covers our Torque Converter 101 basic construction and operating theory. I hope you enjoyed it. Do us a favor, if there's other things you want to see discussed, if you have questions, drop us a comment in the comment section below. Do us a favor, hit that subscribe button. Again, check us out on Facebook, our website, hughesperformance.com. And we hope that you'll tune back in next week. Have a great day.